So let's start with talking about what is current practice, what is common practice. And we have to talk about semantic versioning. How many of you, have you all heard of semver? Have you all used it? You're all familiar with it? No, there's a few blank faces. Good, I don't need to skip these slides then. It's basically an X.Y.Z versioning scheme. And that tends to be how we describe it. And they map onto a major version number, a minor version number, and a patch level. And if we break this down and we look at the patch level first, the basic idea is if your release has fixed a bug, you bump Z up, the end number up by 1. So for example, you'd go from version 1.1.0 to 1.1.1 in your next release if all you've got are bug fixes. That's what you do. Minor versions, that's where you add a new feature and marketing's not twisting your arm and telling you it's a big thing, okay? And the rules are there is you bump the middle number up 1 and you reset the end number back to 0. So that's how you can go from version 1.1.1 to version 1.2.0, okay? And then that leaves the major version number, which is going to be the star of the show tonight, or the villain of the piece, depending on your point of view. So if you add a major feature or a marketing feature, that slide could very easily say, or you break backwards compatibility, which is often overlooked with semver, you bump the first number up and you reset the others. So that's how you go from version 1.2.0, for example, to version 2.0.0. Now, every time we bump one of these numbers, we're not saying there's no bug fixes in there. We're not saying there's no minor fixes in there as well. Sorry, minor features in there as well. We just go to 2.0.0 because that's just how humans normally read these kind of things. It would look weird if we went to 2.2.0 from 1.2.0. So that's why we do it that way. Semver is nothing new. I've mentioned before I worked in the pre-web industry and we had numbering schemes that looked roughly like this and followed roughly the same rules back then. But why semver? Why do you guys choose semver?
Because it's what the cool kids say to use.
It's what the cool kids say to use.
It's all over Twitter about versioning, and it's preached as best practice, I suppose. And when you're learning in the industry, you kind of go with the common denominator.
Oh, those Twitter people.
Yeah.
They're terrible. How about yourselves?
It just seems to make sense.
Just seems to make sense.
You show it to someone, they sort of get it straight away.
Yeah. Yeah. There is another reason people go with semver. And it's the reason these rules have been kicking around for decades, literally decades, is it's actually a kind of a promise between you as a package maintainer and you as someone who uses packages. And it's describing what you can expect when you upgrade a package. See, the basic idea is as long as you stick with the same major version, like version 1 for example, you should be able to upgrade to any of the minor releases or any of the bug fixes, and your code shouldn't have to change. That's the promise you're making as a package maintainer if you're using semver. That's the whole point of it. So for example, I've deliberately picked a ridiculous number here just to make the point. But how many of us build a project and then we don't have time to upgrade all the dependencies for days, weeks, months, even years? Yeah, we've all done it. So you can get stupid jumps in numbers like this, although 46 bugs in a single release being fixed is quite entertaining. But that should be a hands-off upgrade. If I'm using your package and I've pulled in version 1 originally, and then 6 months later I'm pulling in a version 1 point rather large, like 59, 46, I shouldn't have to touch my code at all. I should be able to pull your new version down and my code should work 100%. No problems, unless you've shipped some new bugs, of course, but that's out of scope for this discussion. It should be completely hands-off. If I have to touch a line of code, you've broken that contract that semver promises. Now, I don't know how many of you are aware of that, those of you who use semver. Were you aware of it? It was meant to be that strict?
No, I just know that if I break it, I'll get a lot of GitHub issues.
I found that promise broken, I was very upset.
Yes.
Yeah.
Yeah. Fortunately, with the GitHub issues, you can turn off notifications.
I can, but it makes my repo look really bad.
Oh, don't worry, there's plenty of repos far worse. We might talk about some of them tonight, don't worry. But as you mentioned yourself, it's a real problem when people break that contract. But it happens all the time. It's an incredibly high standard for a package maintainer to hit, especially if you're not doing it for your job. If you're doing it in your own time. Yes, please.
What about deprecations? Always all deprecates a method.
Hold that thought. We're going to come back to that. I've got a slide for that in a moment. Never. But it's because of these backwards compatibility breaks. That's the problem. That's why the bar's so high. Now, what do you think is a backwards compatibility break? Deprecations, right? We're going to come back to that. What else would you call a backwards compatibility break?
Switching PHP versions.
Switching PHP versions. We're going to come back to that.
Anything that breaks your public API, I think any sort of public methods that you may be relying on.
Okay. So changing the API.
Changing behaviour.
Changing behaviour, absolutely. We're going to come back to that as well.
Other dependencies, I suppose. If
Other
you switch dependencies out,
yep.
will require new ones.
I think that's almost a clean sweep of what we've got. Got an excellent team. So changing an existing API, as Oliver said, changing those public methods. That's the easiest one to spot. I think there's tools out there now that will actually tell you if you've changed your method signatures in packages. Probably. Yeah. People seem to be building a lot of things on top of better reflection these days. I think that's one of them that's been built. Changing the behavior of an existing API is often overlooked by people, but not by you guys, so that's excellent. So that's where the method signature change is the same, but if I cut the results change, I'm not getting the same results back anymore. Now, people forget that one way you change behavior is by fixing bugs. And this one is a difficult one. You could do the Linux way, which is if you've shipped a bug, it's now a feature and you can't change that behavior because the Linux kernel, most of the planet runs on it, for God's sake. So you can't change it once you've shipped it. But I would argue for what we all do, fixing the bug's more important than preserving the backwards compatibility, because hopefully more people are going to install it than already have. You've still got new users to discover over time. So I would argue that is a backwards compatibility break that's worth making most of the time. If your library is so big and sprawling that fixing the bug causes major problems for people, perhaps the problem is your library, not the fact you fixed the bug. Maybe. Deprecated warnings. Now, I don't know how many of you are aware, this is allowed in the semver spec. If you go to semver.org and read it like I was yesterday, it says that deprecated warnings are absolutely allowed. That's fine for a compiled language, but in an interpreted language like PHP, this changes runtime behavior. Because if you add deprecated stuff into your packages, all of a sudden my production logs are full of new log messages. And I have to go and change my code to clean those logs up. So I can understand why people do it, but it breaks the hands-off rule for doing upgrades. So for me, this is a no-no. And Zend are very guilty of that. They did it earlier this year because they were preparing for Zend Expressive version 3. So version 2.2, I think it was, of Zend Expressive. Deprecation warnings everywhere because they were preparing for a better API. Not great when you're upgrading packages and all of a sudden you've then got to put time aside to upgrade your code when you weren't planning on it. So that's a problem. One Steve mentioned, changing the package's dependencies. Now, why is that a problem? Why is that a backwards compatibility break?
Because it requires the install of additional packages or the removal of packages you may have added. Like one package I used, I didn't rely on Guzzle, for example, because it was an API package just to connect and a nice wraparound API.
Yeah.
But for speed and efficiency, I installed Guzzle at a later date, which changed what the person had to install to use the package.
Okay.
So to me, that's a breaking change because it's requiring something other than advertised.
Okay. That's one reason. There is a different reason that's may have bitten you, especially as a Guzzle user in the past. All these packages have to coexist inside one vendor folder. So if you change your package's dependencies, you're increasing the possibility of that clash happening. And we're going to talk about the clashes in more details in a moment. It's one of the big problems of backwards compatibility breaks. So that's the big problem with that. And to finish, changing the supported PHP version. Now, why is that a backwards compatibility break? Because this is also allowed in semver. As are changing dependencies, by the way, I forgot to say that.
For me, I suppose it's if you change your package and use any of the newer features in PHP 7, for example, if you want to go a little bit further back for those who don't support PHP 7 and use the shorthand array syntax, the people who may have installed it aren't on the same environment.
Yeah.
So they're going to get massive issues of not knowing what the hell your new array actually is, because you haven't written an array or any of the crazy new things that we're seeing in PHP 7, like the rocket operator or whatever that's meant to be.
Yeah. So environment, changing the supported PHP version means that all of a sudden your package may be rejected on an environment where the previous version of the package would install. For example, people who aggressively are supporting the latest PHP version only. There's a bit of a trend in the PHP community amongst the Twitterati, naming no names, for that as that's something they do. But most of the world runs on cloud and it runs on Ubuntu, which does not keep track with the upstream PHP releases at all. It runs on a different release cycle. So if you're running Ubuntu LTS, which is what you should be using because it's the only one that's bloody stable, and then someone says, oh, I want PHP 7.3 when it ships, all of a sudden you're screwed. You can't install the minor version of that package. And if that's got a security fixing you absolutely need, what the hell are you supposed to do? Now, here in this room, we may all have the skills to, we can build our own PHP version and install it. But most shops out there don't have that skill. And all of a sudden, you're excluding all these users. Because you're assuming, as a package maintainer, you're assuming your users can do everything you can do. They can't. That's one of the reasons they're users and not package maintainers themselves. So hopefully what I'm trying to highlight, if you weren't already aware of it and hadn't already been bitten by it yourselves, is if you're breaking backwards compatibility, it causes a lot of problems for people using your libraries. That's why you're supposed to bump the major version number so they know there's more work ahead. It's not a routine upgrade. And that's why semver wants you to do that. Now, I think we've pretty much covered this question, but can anyone think of any other knock-on effects if you actually bump that version number, the major version number of a package? So what I want you to do is I want you to hold that thought. We're going to come back to it in a moment. Because I want to talk a bit now about how packages work under the hood.